Welcome to this Technical Works Compliance video. In previous videos we've looked at design records and technical decisions. In this video we will focus on performance estimates and the assumptions that sit behind them. Performance estimates are often an important factor in a customer's decision-making process. They help customers understand the expected performance of a proposed system and can influence purchasing decisions. However, assessors are not simply interested in final figures. They are often interested in how those figures were derived, what assumptions were made, and how the information was presented to the customer. Let's begin by looking at why performance estimates matter. Performance estimates form an important part of many renewable energy projects. They influence customer decisions, support the design process, and help establish expectations regarding system performance. Customers often rely on these figures when deciding whether to proceed with the project, so it is important that they are realistic, supportable, and appropriately presented. Good performance estimates help build trust and reduce the likelihood of misunderstandings later. Performance estimates are only as good as the information used to create them. Input data may include site location, roof orientation, roof pitch, shading information, customer requirements, and system configuration. Errors or omissions at this stage can significantly affect the accuracy of the final output. It is therefore important to ensure that the information used is accurate, relevant, and appropriately recorded. Most performance estimates rely upon assumptions. These assumptions may relate to survey information, shading conditions, customer information, future site conditions, or limitations in the available data. Where assumptions are made, they should be clearly documented. This helps explain how the estimate was produced and provides context if questions arise in the future. Good design records should distinguish between confirmed information and assumptions. Many installers use specialist software to generate performance estimates. These tools can be extremely valuable, but they remain dependent upon the quality of the information entered. Outputs should be reviewed carefully, assumptions should be checked, and any unusual results should be investigated. It is also important to understand the limitations of the software being used. Software can support compliance and design activities, but responsibility for the final estimate remains with the installer. Shading can have a significant impact on system performance. Nearby buildings, trees, chimneys, roof features, and future developments may all influence the amount of solar energy available to the system. Seasonal variations should also be considered where relevant. The assumptions used when assessing shading should be reasonable and capable of justification. Where shading information forms part of the performance estimate, the supporting evidence should be retained. Performance estimates should help customers understand what may reasonably be expected from the proposed installation. Predicted performance should be discussed openly. The assumptions used should be transparent, and any important limitations should be clearly identified. Where applicable, required disclaimers should be provided in accordance with the relevant requirements. Customers should understand that performance estimates are predictions based upon assumptions rather than guarantees of future performance. There are several common issues that assessors encounter when reviewing performance estimates. Input data may be incorrect. Assumptions may not be supported by evidence. Required disclaimers may be missing. In some cases, the performance information may be available but not presented in the format required by the applicable requirements. The issue is often not whether the information exists, but whether it has been communicated appropriately. Assessors often review both the estimate itself and the information used to produce it. This may include survey records, design assumptions, supporting calculations, customer-facing documentation, and any accompanying disclaimers. They may also review whether performance information has been presented in the required format and whether it corresponds with the installed system. The focus is often on understanding how the estimate was derived and how it was communicated to the customer. Performance estimates should not exist in isolation. They should form part of the wider project evidence trail and link to survey information, design records, customer documentation, and installation records. Consistency across these records helps demonstrate that the estimate was based upon the actual project rather than generic assumptions. A well-structured job file allows assessors to follow the evidence trail from survey through to completed installation. Performance estimates play an important role in both design and customer communication. Good estimates are supported by accurate information, reasonable assumptions, and appropriate evidence. The assumptions used should be recorded, the outputs should be understood, and the information provided to the customers should be presented in the required manner. When supported by good records, performance estimates can help demonstrate competence, transparency, and effective project management. Thank you for watching this Technical Works Compliance video. If you found this video useful, please consider subscribing to Technical Works Compliance for practical guidance on MCS assessments, quality management systems, solar PV, battery storage, PAS 2035 and broader compliance topics. I'll continue to share assessment-based guidance and common compliance issues encountered within the industry. If you'd like to continue through the series, simply click the next video on screen. I look forward to seeing you in the next video here on Technical Works Compliance.